So today in class we took notes on how to find the Lewis structures, or also known as electron dot structures. And so what I want to do now is I want to go through with you some examples. Remember we said that we're only showing our valence electrons. And to get your valence electrons, you're going to look at your group number on your periodic table. So you want to have your periodic table out to refer to. Also remember that the elements obey the octet rule, which means they want to have 8 valence electrons. There were a couple of exceptions, but we'll look at those once we have done a good number of these Lewis structures that follow the octet rule. And hydrogen, of course, obeys the duet rule, which means he wants to be like helium, and he just wants to have 2 valence electrons. So we said that the first thing you do is you add up your valence electrons for all atoms in the compound. So we're going to sum up our valence electrons. Remember to look at your group number. The next thing we're going to do is we're going to always start off with single bonds. You always assume you use single bonds until the very moment that you have to have multiple bonds. And I'll show you when we do these examples, you will know when you have to share multiple bonds if you follow the steps I'm going to lay out for you here. Once you have connected everything with a single bond, remember a single bond is one dashed line that represents 2 electrons being shared between the atoms. That's that covalent bonding we were talking about in class. You're going to then arrange the remaining electrons to satisfy the duet rule for hydrogen and the octet rule for the other elements. So the examples that I'd like for us to do today are for chlorine, carbon tetrafluoride, water. We're going to do a polyatomic ion here, the cyanide ion, and then carbon dioxide. So the first one we're going to do is for chlorine. So I'm going to write the formula over here for the ones that we're doing. So the first thing we do is add up our valence electrons. So let's look at our periodic table and find chlorine. Chlorine is over here. He is in group 7A. Remember, your group number tells you the valence electrons. So chlorine has 7 valence electrons. Everybody should have your periodic table handy. So remember, we learned the 1A's have 1 valence electrons. The 2A has 2 valence electrons. Group 3A has 3 valence electrons. 4A has 4. 5A has 5. And 6A has 6. 7A has 7. And 8A has 8, but we won't see any of those in the Lewis structures because they're already stable. Remember, the elements are trying to get like the noble gases. So that's why we follow the octet rule. So we're doing chlorine, diatomic chlorine. So what you have to look at is your formula. This formula tells me there are 2 chlorines in the formula. That's what that subscript 2 means. Now each chlorine has 7 valence electrons. So in the parentheses here, the number I'm writing represents our valence electron. So there's 2 chlorines, they have 7 valence electrons apiece. So we're adding up our total valence electrons here, which for chlorine is 14. There's 14 total electrons in the chlorine molecule, diatomic chlorine. So the next thing said, connect everything with a dashed line, so a single bond. So there's 2 chlorines, I'm going to put Cl dash Cl. Now remember, we said in class that for a single bond, that represents 2 shared electrons. So right now, this single bond that we have on chlorine is 2 electrons that I've used so far. So count up how many electrons you've used when you connect your atoms. We've used 2. And come back to your total and subtract. 14 minus 2. These are the 2 that are shared between the atoms. And now what you're doing is you're trying to figure out how many electrons you still have remaining that you need to distribute evenly around the atoms present to get the octet rule satisfied. So 14 minus 2 leaves me with 12 electrons that I need to place around the atoms. Now it's very important that you understand the elements want to have 8 total. So when I start distributing my 12 electrons around my chlorine, I'm going to make sure that before I leave the chlorine, I will have finished his octet. So I'm going to start putting these as dots. These are the dots because they are not being shared between the atoms. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I placed all 12 of my electrons that were remaining around the chlorines. Now, if you were to look at the first chlorine here and count what's around him, he has 2, 4, 6, 8 electrons around him. And if you look at the second chlorine, 2, 4, 6, 8 electrons around him. So each atom now has its octet, and I have finished the Lewis structure for chlorine. The answer for chlorine Lewis structure is Cl-Cl, and then all of the electrons are distributed evenly till the octet rule is satisfied. So this is your answer. All right. Now let's look at the second example. The next example is for carbon tetrafluoride. So notice example 2, CF4. Now I've underlined the carbon here because he's going to be my central atom. Let's add up our valence electrons. This is our periodic table. We have carbon. There's one carbon. He has 4 valence electrons. And the fluorine in the group 7A, they have 7 apiece. And remember, you have to account for all of the electrons. So carbon has 4 valence electrons. There are 4 fluorines, and they have 7 apiece. So 4 plus 28 gives me 32 total electrons. This is your total electron here. The next thing you do is you connect everything with a dashed line. So put your carbon in the middle. I underline him because he's your central atom. And we're going to connect the 4 fluorines to him. Keep it symmetrical. I treat the carbon like he's in a square box. So I put something on the top, the bottom, and the left and the right. So I'm going to put the 4 fluorines, distribute them evenly around the carbon. Carbon is the central atom. That means everything goes around him. Now add up the electrons you've used so far. I've used 2, 4, 6, 8 electrons. Again, each dashed line is 2. 2, 4, 6, 8 electrons. So come back over here and say 32 minus 8. And when you subtract 32 minus 8, that gives you the remaining electrons that you have. So when you subtract, you get 24 electrons that you're going to now place around the atoms that need them. Now if you look at carbon, he already has 8 around him, so you don't need to place any more around the carbon. That means you're putting all of your dots around the fluorine. So I'm going to distribute them in pairs. Remember, these are our husbands and wives. The positive 1/2, negative 1/2 being electrons that we learned about in the last chapter. So 2, 4, 6. That finishes off fluorine. Now he has 8. 8, 10, 12. 14, 16, 18, 20, 22, 24. And that's what I had. I had 24. I've used them all up, so I'm finished. If you check the octet rule, carbon has 8, and each of the fluorines have 8 around them as well. That is your answer for carbon tetrafluoride. Let's look at the water molecule. Okay, I underlined your oxygen, which means he's your central atom. Let's look at our periodic table. Add up our valence electrons. Hydrogen has 1 valence electron apiece. Oxygen is in group 6A. He has 6 valence electrons apiece. Let's go back. So there's 2 hydrogens here, so I got to say 2 times. They have 1 apiece. Plus, there's only 1 oxygen there, and that oxygen has 6 valence electrons. That gives me 2 plus 6, which gives me 8 total electrons. Put your central atom down first. Here is oxygen. Connect your hydrogens to him. H-H. Connect everything with a single bond. I've used 2,